Hi, my name is John and welcome to another edition of Statistics Quest. I'm going to look at a series of episodes that have to do with probabilities of rarities or records in Major League Baseball. And the first one I'm going to look at is that of Joe DiMaggio's 56-game hitting streak back in 1941. Before doing that, though, I'm going to touch upon a few key things, so bear with me for a few minutes on some of the foundations that have to do with probabilities. And one is, what question are you asking? And the other is, what assumptions are made? And these are very important things that sometimes get a little bit glossed over in either asking a question or sometimes in somebody, perhaps a mathematician, delivering an answer to a question. In fact, there was a famous game theory problem that was, I believe it was called the Monty Hall problem, and had to do with let's make a deal. And as I recall, it went something like this. So let's just say you're a contestant, right? And there's three doors, and two of them have goats, and one of them have a real prize, okay? And you pick door number one. And before opening door number one, Monty Hall shows one of the other two doors. Let's say it's door number two, and he shows a goat behind door number two. And the question is, should you switch to door number three, or door number one, which you don't know anything about? And I believe Marilyn Vos Savant had originally posed this maybe 30 years ago or something like that in one of her columns, and suggested you should switch because there is a 1/3 chance that you picked the one of the goats originally, and therefore there is a 2/3 chance that if you do switch to the other door, that that would be the winning prize. A lot of mathematicians wrote into her, some PhDs, and said, no, this is not correct, etc., etc. Well, it ended up that Marilyn Vos Savant was borne out that she was correct. But an important thing that, and in fact, I remember, I think I wrote a letter somewhere saying, wait a second, it depends on assumptions, okay? And those assumptions weren't talked about back then. In fact, this might have been pre-internet, but now on the Wikipedia page and others, they clarify, well, it depends what assumptions are made. And just real quickly, I'm going to go over that. In fact, you can find this on the wiki page, and it does say that there are three standard assumptions. And I'm just going to talk about them real quick. One is that the host must always open a door that was not picked by the contestant. Two is that the host must always open a door to reveal a goat and never the car. And three is that the host must always offer the chance to switch between the originally closed door and the remaining closed door. Now, many people might say, well, yeah, those are standard assumptions as part of the game, let's make a deal, right? But again, in mathematics, things really should be specified. So were those mathematicians back then that disagreed with Marilyn Vos Savant incorrect? Not really. It just really, they had a different set of assumptions. Again, some people would say that they were incorrect because they should have assumed what most people were assuming, which was that they were playing by the let's make a deal rules. But anyway, I just wanted to briefly discuss that. I'm not going to, if you want to check up further on that, feel free, but this isn't about that game. This is actually about, in this case, the Joe DiMaggio problem, okay? But I want to make a point that assumptions are important, and not only what question are you asking is important. Okay. So getting back to DiMaggio's 56-game hitting streak, okay? So we can ask this question in a lot of ways. We could ask, what was the probability that Joe DiMaggio ever got a 56-game hitting streak in his major league career? We could ask, what is the probability that Joe DiMaggio did that during the 1941 season? We could ask, what is the probability that he did it during any particular season? We could ask, what is the probability that he did it on a particular 56-day chunk in 1941 or in any year, okay? We could ask the probability that anybody, the average player, did it. So lots of ways you could pose the question, okay? Now, in retrospect, people, of course, knew that it happened, right? And so 10 years, 20 years, 30 years later, they were asking the probability that this happened without specifying, as I just did with some examples. So, I'm going to read between the lines a little bit. And think, well, okay, what is probably often meant is beginning on that particular day, and I forget when it was, maybe it was sometime in May that it started. What is the probability that he had at that point would get a 56-game hitting streak? Okay. Oh, by the way, another way you could word the question is, what is the probability that it's at least a 56-game hitting streak, which is a different question than asking exactly a 56-game hitting streak. Now, all of these might seem kind of trivial and so forth, and you might be thinking, John, get on with it, but they're really important to clarify if you want to correctly, or as correctly as you can, answer the question. So we are going to ask the question, what is the probability of DiMaggio having a 56-game hit streak in a particular 56-game stretch in any year, actually. But in this case, it's 1941. Okay? Now, I said any particular stretch in any year. We're saying 1941. Well, so we could look at, let's say it's 1941, and you have game 1, game 2, right, through game, I think they played 154 games back then. Okay. So you could ask, well, what's the probability of the first 56 games of him hitting safely? Right? Or 2 through 57, 3 through 58, etc., right? So there's quite a few different 56-game chunks that we could have asked about. I said any particular one. Well, any particular one means kind of pick one. In other words, it doesn't matter whether it's 2 through 57 or 1 through 56 or 31 through 96. 31 through 86. Okay, that would be 56 games. Pick one. But you can't include all of them. Because if you include all of them, meaning all of 1941, you're actually asking a different question, and therefore it requires a different answer. Because if you ask what's the probability he did it in 1941, you're really asking what's the probability that he did it either in games 1 through 56 or 2 through 57 or 3 through 58, etc. So that's why, even though it was some particular stretch, right, maybe it was game 30 through 85, I'm not sure what it was, but we can ask what's the probability that it's any particular 56-game stretch, because it would be answered the same way. In other words, if we ask 3 through 58, we actually answer it the same way as 1 through 56, etc. Each of these would be answered the same way, but we can't just put them all together and say, well, okay, well, that comprises 1941, because it would actually be more, because you have more possibilities to do it in either 1 through 56 or 2 through 57, etc. Okay, so so to set the scenario, it's kind of like you wake up one day, okay? It doesn't matter if it's May 4th, June 4th, whenever, and say, I wonder what the probability is that Joe DiMaggio at this point is going to have a 56-game, at least, hitting streak, okay? Now, we need to make some assumptions, okay? The probability of him getting a hit. Now, so there are different ways to go about making assumptions, right? We could do projections, which, he ended the 1940 season with a particular batting average, so many walks, etc. And we can say, well, in 1939 he did, and then you project, right? So you create a regression model and you project what he's going to do for 1941. You know, I didn't do that. It's going to be probably pretty similar to his 1940 batting stats. So I'm just going to use his 1940 batting statistics as part of the assumptions for his likelihood of getting a hit on any particular plate appearance in 1941, okay? All right, now, what are other assumptions? I'm going to assume he goes to the plate 4 times a game, okay? That's probably a little bit understating it because the Yankees actually had some very good teams. And DiMaggio batted at the top of the order. I think he batted third. So he probably went to the plate 5, sometimes maybe 6 times in a 9-inning game, but we're just going to leave it at 4 just to simplify things. We're also assuming that he's going to play all 56 games, okay? So if we are understating the likelihood with this, we're probably overstating because I'm going to assume he's playing all of the games. And, you know, that's a little bit, especially DiMaggio. He had, I believe, spurs in his heels, and so he had some injury issues. But anyway, okay, so we're going to assume he goes to play 4 times again. Now, with regard to getting a hit, you either are going to get a hit or not get a hit. It doesn't matter whether you walked, got on an error, or whatever. Okay, walking may not affect your batting average, but it does affect the likelihood of getting a hit, right? So in effect, it's still a non-hit. Right? So whether you walk or not, doesn't matter. Did you get a hit or not? All right. He got a hit .313 of the time. And that doesn't mean that's what his batting average was. His batting average was actually better, but if you look at his plate appearances and you divide his hits by plate appearances, it's .313, so that's the likelihood that he gets a hit. Okay? Now, so this is where we get into some basic probability, okay? And so for any of you that, you know, might be college students or you're trying to learn about basic probability, these next few minutes hopefully will help guide you there. And probability is one of my most enjoyable things in the world of statistics. I think everybody should learn to think in terms of some basic probabilities. I think it can help guide you in life. I'm a little bit biased, but anyway. And it's not hard. These are some basic concepts, as you'll see in a second. So, probability of getting a hit is .313 at any particular time he goes to the plate, okay? So what's the probability that he gets at least 1 hit in 4 trips with this assumption? Well, we can do this indirectly, okay? We could look at the probability of getting either 1 hit or 2 hits or 3 hits or 4 hits, but it's a little bit easier to look at the probability. Let's look at the probability of getting 0 hits and then take the complement of that, okay? Well, let's see. If the probability of getting a hit is .313, then the probability of not getting a hit is .687. That's just 1 minus .313. So the probability of not getting a hit is .687. If you have to not get a hit in 4 trips, that means you get no hit, no hit, no hit, no hit, right? Well, you just multiply .687 times .687 times .687 times .687. And again, that's one of the most basic concepts in probability. If you want to find the probability of 2 or more events happening, just multiply the respective probabilities. .687 to the 4th power is .223. That is the probability that he does not get a hit on any particular day. Well, if that's the probability that he does not get a hit on any particular day, then the probability that he gets at least 1 hit is just the complement of that, or 1 minus this. So the probability of getting at least 1 hit is .777, right? 1 minus .223 on any given day. Now, we use a concept again that we just used. What's the probability that he does this 56 straight games? It's 0.777 raised to the 56th power, because we need 56 things to happen. Namely, that he gets at least one hit each of those 56 days. The probability on any of the days is 0.777. We raise it to the 56th power, and we get 0.000007. That's 7 in 1 million. That's pretty rare. Now, I also said, technically, you have to ask, what's the probability of getting at least a 56-game hitting streak? And the reason I say at least, because if you happen to ask the probability of exactly a 56-game hitting streak, you got to attach one more thing. Because if it's exactly a 56-game hitting streak, that means he did not get a hit in the 57th game, which would mean you'd have to multiply this whole thing by 0.223, because you're suggesting that he did not get a hit in the 57th game. So, some nuances. Now, again, so you look at the rarity of this, and this kind of begs another question. This is the way you would answer the particular question posed. What do people mean? Did they mean it was on a particular 56-game chunk of games? Did they mean it at any point in 1941, which is what a lot of people might have meant? Or did they mean it at any point in his career, right? There was nothing special about 1941, okay? So, in other words, if he would have done it he was in the war 1942 through 40, or 43 through 45, I believe. But anyway, if he would have, 1947, if he would have had a 56-game hitting streak, and we're talking about it 70 years later, okay, we'd still say 7 in 1 million. So, but that's a little bit distorted, isn't it? Because he had a lot of chances to do that. He didn't just have one 56-game chunk to do that. He had many 56-game chunks within a year, and then he had many years with which to do it. So, that's where you get to, how rare is it? It's rare, but this probably overstates the rarity, meaning the true rareness of it, what is it, okay, is probably a little bit higher. And then just to follow up on that, what if we did ask the probability that he did it at any point during his career? Oh my goodness, then you get into some really, really heady stuff, because then you have to look at all these 56-game chunks. You get into dependence, because if he didn't do it in one particular, let's say game 10, it just really gets messy, and we're not going to ask that. So anyway, here's the answer to the way we worded the question, okay? Hopefully you understood the probabilities. Pretty rare, okay? We're going to look at some other rare things in the upcoming videos, but for now, we'll leave it at this. And I hope you liked it. Don't forget to hit like if you haven't. Ask any questions or comments, and I will get back to you. Thank you for looking, and see you next time on Statistics Quest.